Hello, interested parties into the Lowell Institute School and the Northeastern University's College of Professional Studies bachelor's completion arena. For those of you who are watching this, you're likely either a student, a part-time faculty, maybe an administrator, or a teammate within the College of Professional Studies, or you're one of our external partners who are just interested in pathway work, the ways in which we're working with students to build out an incredible opportunity for students to enter into a variety of academic programs, upskill into the profession they are aspiring to be in, and hopefully land a meaningful job that leads to a meaningful career, that leads to an ability to make a living wage in a really complicated 2025. I am joined today by two individuals that I'll have introduce themselves. Krassimir Marchev, he runs our advanced manufacturing program. Can you come on and introduce yourself, Krassi?
Thank you, Chris. I have long association with Northeastern University. I have interdisciplinary PhD from Northeastern. I spent 20 years in industry and I came back in 2017 with the task of lead the advanced manufacturing program in close cooperation with industrial partners. So ever since, I have been having a lot of fun working with partners such as General Electric and number of other companies. And the program has gone quite a lot ahead in many different respects in response to the needs of our industrial partners and the American economy in general.
Beautiful, thanks. And Giumarra, why don't you come on and introduce yourself as well?
I'm Giumarra. I'm an associate professor teaching mostly electronics and automation courses within the advanced manufacturing program. So for the past 4+ years, I've been developing and teaching electronics, mechatronics, automation, robotics, and some math and physics.
Awesome. Guys, thanks for joining me and the collective of folks who are watching this as well. I think people just want to know generally, what do students study in the realm of advanced manufacturing and or mechatronics as they embed themselves in our program?
The unique thing about the advanced manufacturing program is that we are very highly focused on industry, particularly in aerospace industry. This is how the whole program of advanced manufacturing was initiated by close cooperation with General Electric Aerospace in Lynn, Massachusetts. We worked together with the team from GE to define what are the learning objectives and what competencies and qualifications their employees who go through our program should have so they could be successful in what they do. We started from there. We expanded the program to other facilities within General Electric facilities, of course. And then we had very strong focus in Western Massachusetts, where number of suppliers of GE and Pratt & Whitney are located. So we partner with the Springfield Tech Community College. And as we move further, we focus our program development and training on skills that are necessary for today's engineers to succeed in the manufacturing fields. The word manufacturing by itself, I think, is clear to everybody. But the important word over here added to this definition is advanced. So we focus all our efforts to identify which are advanced methods and techniques currently used, which could make the manufacturing faster, cheaper, better, and more successful for everybody. So this is where we started, and this is where we are going. So we are in constant cooperation with industries, not only aerospace industry. We have students from a number of other industries around Massachusetts. Right now, we are expanding and growing the program to go very deep into the medical manufacturing. We have a number of students from pharmaceuticals, from gun industry. So again, we are giving students skill which make them succeed in different industry. And it is a common practice that our students transition successfully from one industry to another industry and get better jobs and well-paid positions.
Appreciate that framing. Let's turn to Jim. Can you give us a little bit of sense of mechatronics program and how that connects into a manufacturing process?
There's a lot going on in the manufacturing space these days. There's tremendous investment, both privately and publicly, all across the country in practically every state. There's just a national push, and there has been for years, for onshoring and reshoring and bringing all sorts of advanced manufacturing back to the United States. These are good jobs, interesting jobs, cool jobs. They're not going away. There's millions that are going unfilled. It's really a point of national pride to get involved in manufacturing. We need more people in this space, and they're good paying jobs. Some of the topics that were mentioned at the recent Next Generation Manufacturing Summit that I attended were advanced materials, and AI is helping with that to develop new materials. Biomimicry is a big trend, using nature as inspiration to develop systems, all sorts of autonomous systems to automate everything. And this automation has been proven and shown to create many more jobs. You would think that at some point you're automating yourself out of a job, and there is some media that would claim that, but it just hasn't been true. There's no data that says it. All the data says that it's creating more jobs, and the skills you need for these jobs are more advanced. So you need training and education, but there's a lot of training available. Global positioning, tracking parts and things at every step of the manufacturing process. Electrification is a huge trend. Battery technology is huge. Machine vision, as I mentioned, is something that needs to get better for certainly humanoid robots to be something that we could take full advantage of. And who is manufacturing for? And at this summit I attended was on who is right for manufacturing. And it is literally everyone. There are huge pushes for women in manufacturing. We need you. We need your perspective in this space. Mechatronics refers to a mix of electrical and mechanical engineering with computer control. It's an umbrella term which encompasses many topics and fields, including automation and robotics. It is so broad that what you would learn in a course like this would depend on the institution. And in some courses, you could learn some basic CAD, computer-aided design, and it would also include our course, specifically the basics of PLCs, programmable logic controllers, and ladder logic, which is the most common way to program these programmable logic controllers.
So, Krassi, I want to work in the air industry, and I want to work in a factory, or I want to work in a plant, or I want to work in a company that builds airplanes. How does this connect? What does that look like? What are some of the roles, and how do our courses prepare you for that work?
This is a very good question. Let's start with this. What is the product of advanced manufacturing? What is the difference between today's products and yesterday's products? Obviously, as example of industry jet engines and so on and so forth, we have gone very far ahead. We have invented new materials, new designs. This lead to high performance. The expectation is for anybody who is in this industry that people understand the design, that people understand how to properly execute certain sequence of steps or assembly instructions and so on and so forth in doing that. So what we are contributing over here, we are taking a step back and we are giving people top-down understanding, not only how to execute instructions, but how to generate these instructions based on in-depth knowledge and understanding of designs, of materials, processes, quality control, and so on and so forth. So literally, we are closing the whole cycle. And in addition to focusing on engineering, we prepare people to become leaders, to be able to stand in front of their team or their teams to present and defend their ideas and make it in an engineering form that makes sense, that is statistically proven, and all decisions are data-based. And that makes a huge difference. So when they're in a situation to make justified, educated decision, they understand the advantages and deficiencies of all these methods. So we give them all this and add to this the training which we provide in a supply chain. We have a couple of courses in supply chain. All this allows us, and I can honestly say, I think that when people graduate from our program, they take higher positions in their companies, so they transition to other organizations.
Mechatronics in industry is also a bit strange. Some of the larger companies will have mechatronics groups, and typically you're in charge of things or working with things that are electromechanical, transformers or relays or motors. But you'll work in a team, and your position could be mechatronics engineer or technologist, technician, or you could be an automation engineer or robotics engineer, controls, instrumentation, PLC, test engineer, electromechanical engineer, maintenance engineer, manufacturing engineer, process engineer. So you could study mechatronics or automation and robotics and have your title be one of those things. And your role could change a bit, but in general, you are trying to increase the safety or efficiency of your system, whatever you're making. In the industrial environment, if you're manufacturing or processing, you will see conveyors, robots, maybe pick and place, robot arms moving material from one work cell to the next. There could be machining involved, which is removing material from a block of metal or some other object. There could be injection molding. There could be 3D printing, which is additive manufacturing by adding materials, even metals these days, to other materials. There's welding. There could be hole punching, cutting, bending. You can have a bending station, and often you're moving from one station to the next with robots. So generally, you're trying to make that process more efficient or safer. And no system is 100% efficient. You could always get better. So you're always trying to make it 1% better or 0.5% better. So you could be working on projects to improve productivity, efficiency, and safety. You could be working in R&D. You could be working on trying out a new vendor, a new component in the manufacturing line and taking data on that, and then look for mistakes that keep happening and look for solutions for that. I had a former student working at a robotics company, and their their warehouse robots that would roll out on the assembly line. Other robots would be assembling the robot. Actually, there were humans also in the loop assembling that warehouse robot, and then they would roll off the assembly line and go off on their own to test. But sometimes every 20th one or so, I forget the number, would just stall. So then my former student would have to take that one, figure out what happened. And he eventually figured out that a certain motor had to be adjusted at the front of the assembly line so that this would never happen. So he looks for systematic errors and comes up with solutions on how to fix them. And that's generally what you're doing. You're looking for these errors. These days, people still think of it as dark, dirty, and dangerous, but it really isn't. It's fast, it's high tech, it's high speed, it's clean. and it's interesting. And there's a lot of different information and skills that go into designing and building any product.
So fascinating to listen about Jim, in particular, the concept that advanced manufacturing is perceived as kind of this dirty, rough and tumble place. And in reality, maybe in the modern experience, it's quite the opposite: high tech, clean, et cetera, as you've indicated. With the infusion of AI, right, there's wonderings about who's going to lose their jobs in many fields. And I have to imagine that some students or folks watching this might be wondering about how that is applicable in the space of advanced manufacturing and mechatronics. Though I don't know the technical elements, I do firmly believe, and as Krassi, you talked about developing managers or leaders within the space, the human element of working in these spaces is almost going to be more important, because the speed at which we executed all these things is going to need people that really truly understand how to put the systems together.
AI is a powerful trend that cannot be stopped. It is ultimately a tool that we should become familiar with using to make ourselves more productive. For our coursework, we do recommend and teach students how to use LLMs, specifically on how to be more productive in some areas. In some of what we do, in a lot of what I teach, it is just not helpful. Like circuit analysis, it's just not good at analyzing circuits, which are pictorial. So it just can't do that yet, even simple circuits. For my digital logic class, it proved to offer the wrong answer many times when trying to analyze Boolean algebra. And for ladder logic, it's a little better at ladder logic because it's more of a logical sequence, but it makes significant mistakes. As far as in industry, AI is good at is finding patterns, and companies use these MES systems, manufacturing execution systems, which is umbrella software that pulls in all the data from sensors from all through the system. And then you want to analyze it and see, again, how to make your system more productive, where some potential hazards might appear. It can detect, a motor is a little bit shaky. It may be starting to fail before a human could ever detect that. One of the big areas for AI is simulation software. Huge right now. There's a lot of talk about digital twins, where you can create a virtual system that matches your physical system, and you're testing it and changing it to see what would be the result. Does it make your system better or slower or more efficient? Or if you're going to create a new system, you build it first in the virtual world, and many companies have these, AutoCAD and Fanuc robots. There's so many of them out there. And so you build your entire new factory virtually, and you can even put on VR glasses and walk around in the space and see, does this work for me? And you could have every one of your employees put on the VR glasses, or even put it on their phone or iPad and say, this is your workstation. This is where you'll be every day. Tell us what you think. And someone say, I have a huge material that has to come through here. I can't swing this material by this pole. Okay, so we move the pole. Or I don't want to look at this pole all day, so we move a structural pole. There's other things to move it besides poles. Maybe the flow of the process doesn't match ideas. You might have someone in a different group have a different idea. Yeah, there is a lot of fear and anxiety about AI, and there's also a lot of hope too. What we've seen with automation is it's actually creating more jobs in the manufacturing space, not fewer. the skills that you need are more advanced to enter and succeed in the high-tech manufacturing sector, but there are more opportunities. But there are still very dynamic roles that you need humans in the loop to manage and to control. Perhaps one day there will be a humanoid robot with advanced ultra intelligence that can do every single job. But for decades to come, we're still going to need more and more people in the manufacturing space to fill the need.
That's a fascinating statement and should inspire our students to know that they've chosen academic pursuits that should be helping them in their careers and in their livelihood for decades to come, as you've indicated. Krassi, what's your take on the AI integration into the field and worry points or points of inspiration?
My opinion is that AI has its place, it has its value. As far as I approach the use of AI, I strongly believe that it is extremely capable in collecting, providing data, and analyzing the data, but at the same time, AI relies on their own algorithms and their own analysis, and this cannot in any way, shape, or form eliminate the human intelligence. You cannot implement any solution without understanding it in depth. I firmly believe in the interdisciplinary approach and understanding, and I think this is well proven. We have significant advantages from AI when we develop new materials because we can input all kinds of thermodynamic data and predict what is the space where we could identify and develop new materials, and there is a strong record of that. So we highly encourage our students to use AI as a source, as a tool, but as far as their decisions, how to proceed, how to implement technologies in manufacturing, how to collect and analyze data, this is something that I believe that will be very strongly impacted by the human factor. And this is what we try to do. We try to teach students to understand in depth all this and know how to implement it.
Awesome. All right, guys, I'm going to turn the conversation a bit. So far we've been talking about what you learn, what context you learn, why is it important, how does AI implement, but we haven't really touched on the question that is related to the title of this series, which is Mentorship Matters. And in the context of I know both of you to be proficient educators and excellent instructors. I also know that you have robust backgrounds inside and outside of academia, and would love to, how did you find yourself in the space of advanced manufacturing and mechatronics or related fields that you've been in for your careers? And how did mentoring play a role in that? Your early move into this space. Krassi, I'd love to start with you. Who was an early career mentor that helped you understand that this is a space that really we were very passionate about?
Let me start by saying that I came to United States, especially to Northeastern University, because of a person who I knew from his publications and from his work. That was Professor Bill Giesen, who became my mentor and my PhD advisor. And over the years, I worked with Professor Giesen for about 11 years full-time, because after I got my PhD, I accepted the invitation and stayed as full-time employee at the university before going to industry for a 20-year journey. So Bill Giesen was somebody who moved in 1968 from MIT to Northeastern. He was absolutely passionate, intelligent. I learned from him to look in depth, to look from different perspectives. And that's something that I'm trying to share with my students, because if you understand things in depth and if you have passion, you can discover new heights. And that is the way to do it. So I firmly believe that on the mentorship front, it is part of my mission to engage my students and engage other faculty, engage part-time faculty who work in our program and work as a team. Because how should I say? I wouldn't say exactly that students are our children. In a way, I feel that it is my mission and the mission of other faculty members that we engage and translate what we have learned. And I think this pays back. I'm thankful to all my students. We have outstanding connection, which motivate them to do better, to go more in depth, to show how much they know. And I think this is something that we have already embedded in the advanced manufacturing program, and it definitely pays off.
Thanks so much for that. Jim, I'd love to flip the question to you too. Who was an early career mentor, academic, industry mentor that really helped inspire you into the field?
That's a good question. As an undergrad, I studied physics and math. I didn't really know what I wanted to do, but I was pretty good at it, so I decided to study that. I was a B student. There were certainly classmates that were much better academics than I was. Certainly, I did better in courses that inspired me, or there was a dynamic professor involved. When I was a junior, I taught a course called The Science of Sound with a lab. And that's where I really distinguished myself. My students gave me very positive verbal and written feedback on my course. And that's when I knew, okay, this is something I'm good at. I have this skill and I enjoyed it. So I knew eventually I would get into teaching, but I wanted to get out there in industry and make my mark on the world and make money. I had a job at graduation time in the computer industry, but it really wasn't my field. And my advisor in college, who was a mentor, but I never had a structured, stated mentor. You're my mentor, I'm your mentee. It's just people along the way that offered advice, that offered their time, that offered their knowledge. So really only reflecting now, you can look back and say they were very significant mentors. And this individual had a student from 2 years prior that graduated that was working at Argonne National Lab out in the suburbs of Chicago, a very famous lab, as a research scientist. And he was looking for a research assistant, and he got us together and we hit it off, and I applied and I pivoted there and I went to work for him. And that was a significant change in my path, which exposed me to amazing things. While I was there, I worked on superconductors, which are conductors that have zero energy loss. You may know that the energy that is generated at power plants, only 30% of it gets to your home to be utilized. 60 to 70% is lost in transmission. Superconductors have zero energy loss. The holy grail would be to utilize superconductors to improve efficiency, lower cost, and improve profits. However, you need to cool these things very cold using liquid nitrogen and liquid helium. So the room temperature superconductor is still being sought after. So he set me on that path. And then while I was there, amongst thousands of cutting edge researchers, I just kept my eyes and ears open. I talked to everybody. And thinking back, some of the best mentors were what they called the blue shirts. The guys and ladies, although most of them were guys at the time, they were technicians and technologists that supported the PhD research scientists and the graduate students on their projects. And there were so many cool, amazing projects. But they loved to tease the grad students and give them a hard time. I didn't mind that. I gave it a little back to them. I would sit with them sometimes at lunch, and they provided a lot of great inspiration and knowledge for my career. I did that for a year, and after a year, they knew I was looking for something else. And one of the research scientists said, if you want to study electrical engineering, we'll pay for your grad school, we'll give you a stipend, and we'll have you work on our ultracapacitors project, which is these energy storage devices. And at the time, it was for electric vehicles and radar and other things. So I said, heck yeah. So I applied to that and got accepted. And so then my field became thin films and semiconductor manufacturing. When I graduated from there with Mike Lanigan, my advisor and mentor, it was really some hotbeds around this country where that work was happening. The most famous would be Silicon Valley, but another important area was and is still Boston. Since my brother was already living here and I was an East Coast guy, I came here to Boston to work in the semiconductor field. And then something was missing. My heart was tugging on me. And I saw this ad in the Boston Globe for Ben Franklin College looking for professors. I put on my suit, went down to talk to the dean. We hit it off, and I got hired to teach math and physics, and got promoted to chair that department for a couple of years. Then an electronics position opened up, teaching electronics in that department. So I moved over there, and then I eventually chaired that department, and we taught many different things: electronics, computer engineering technology, biomedical technology. And I noticed around the country, my colleagues were experiencing a surge in enrollment when they incorporated automation, robotics, mechatronics, these types of things. So I set about learning more about these topics, creating courses, and then another course, and then a whole track in this discipline, which attracted more students, more companies were interested. They wanted to know what we were doing. They wanted to hire our graduates. And I got to experience a lot of different cool stuff and cool projects. And just along the way, you get encouragement from sometimes it's bosses, sometimes it's colleagues, even getting inspiration from my students and their stories has been very helpful. And what Krassi mentioned about some of the part-time instructors we have, they have a lot of experience in industry, absolutely. But teaching is also a skill. So to be able to mentor them in the craft is important and rewarding.
Yeah, there's these very nebulous words in our business or in the English language, like partnerships or mentoring or any real engagement term, networking. And sometimes they're interchangeable, but often I think narrate the multi-directional nature of those words. So and really appreciated listening to both of you in your description of what how mentoring has played a role into your own career development. It's very rarely formal. And students of ours might go on to a professional setting and you might get a formal mentor at your first job, right? Sometimes it's a colleague who maybe a couple years further into their career and maybe went through the ropes a couple times can give you the pointers, or it's the random lunches you're having with people that share the space with you that maybe provide feedback. But it typically is somebody that demonstrates a little bit of interest in you as a person and your development. But more, I think it's the mentees responsible. And Jim, it sounds like you've done this in all the contexts. Keep your eyes wide open on who could potentially support your journey and be really attuned to that opportunity and look at all moments and all interactions, all partnerships, all networking as a way in which you can serve as the mentee or the mentor in that relationship. And just know, I want you to each give it imagine all of your students right now, past, present, future students were right in front of you, and you had a chance to say, how should you approach your work when thinking about a mentor-mentee relationship, and how might you seek out or have a mindset that will help you elevate beyond just the academic components of your program? So in the world of mechatronics, in the world of advanced manufacturing, what advice do you give to your students when the word mentorship is brought up? Krassi, we'll start with you.
The first thing what I would say is that this is a two-way street. I learn almost as much as I learn from my students as they learn from me. And this is of great importance. Another thing what I want our current and potential students to think about is that they bring a lot of value. Most of our students, they have already experience in industry. Some of my students assemble jet engines. They are very good at that. Some of my students make weapons, some work in the pharmaceutical industry. All of them are well established in what they do at the level where they are. So the way we organize the advanced manufacturing program, we enable extensive discussions and communications every single week. And after these people spend some time in one course, another course, third course, they develop this relationship and people understand their value, they understand the value of others, and they understand how to engage me and how to engage other faculty members.
Love it. Jim, what's your advice to your folks?
I think in general, you want to start with communication. It doesn't have to be such a structured relationship or even event. Just a text, how would you handle this situation? Or just asking for advice about a certain topic, something happened at work. Some of my students send me pictures of systems that they're working on at work, just if they're cool. Some of them ask me questions about it. I'm like, you know better than I do, it's your system. But to share a little bit about their lives and be open to different opportunities and different pieces of advice, really from anyone. You'd be surprised. You can learn from anybody. So definitely keep the communication open. I know sometimes students are reluctant to reach out to their professors. Maybe they think they're bothering them, or to other colleagues, but it's not the case. It doesn't have to be an hour-long conversation. It can be just a few texts or a short phone call or meet for coffee or an email, some kind of communication. Keep an open mind and stay positive. Be calm. There's a lot of things going on. Students have very difficult lives. Just one step at a time, little by little, and keep your eyes and ears open.
Beautiful. Jim, Krassi, I really appreciate the time you've set aside to have this conversation. In the world of advanced manufacturing and mechatronics, it's what you've described is a very human-centered approach to supporting students in your program. And I want folks that are both current students and those who might be interested, or partners who might be interested in kind of thinking about ways that we might develop pathways together, to know that these are two of our leaders in the College of Professional Studies. And I think it's quite clear how much they care about the human interactions and the mentoring in lots of different directions that ultimately create individuals who are successful out of our programs. And so thanks for modeling that. And really, this was a conversation, and I feel like you guys exemplified that tremendously. So thank you. And that should do it for this week's Mentorship Matters.